Happy Thursday afternoon. First, we're going to continue with the trig functions and chain law. What kind of function are we dealing with here?
Power.
Yes. So we use power rule, right?
Yep.
What was being raised to a power?
Sine to t.
What's the derivative of a sine function?
Cos.
What were we taking the sine of?
Cos 2t.
We were taking the sine of cosine.
Oh, yeah. It's 2t.
What is its derivative?
2.
All right, so there's the derivative. And so go step by step. What would be the first piece of the derivative?
3 cosine squared
3 cosine squared what?
of t squared plus 3t plus 1.
Is that it? Or is there more? There's more. All right, so then what is the next piece?
Time multiplied by negative sine to the t squared plus 3t plus
Is that it, or is there more? And what is the next piece?
1. The derivative is
Which is?
2t plus 3.
Is that it? So what kind of function?
Multiplicative?
So what's the rule?
Oh yeah, product.
Give me the first term.
Sine of 5x. No? Yes.
Is that it? Just sine of 5x?
Times 2x.
Plus. Second term
cosine of 5x?
Is that it?
Times x squared.
Could factor out an x. Don't really know if that's going to be beneficial. Let's just leave it like that. What kind of function? So what kind of function are we dealing with? So you could use product rule, right? Do you have to?
You could make it.
We could rewrite this using the product to sum identity. Which would then remove the need to use product rule. It's really just a matter of how you want to go. I don't feel like doing product rule. Sine of t squared plus 8t minus 7. Then minus sine of t squared minus 2t plus 7. What kind of function is that now? broader.
Oh, when we distribute that, we're just gonna turn that into a potion. No.
Stick the top on the side.
Isn't that a constant multiple? It's a constant times a function, isn't it? So constant multiple rule. Half times the derivative of the function. Now it's difference. That's a nice easy rule. Let's go term by term. What is the derivative of the first term? What is it?
2t
Just 2t?
plus t.
Is that it?
I guess not.
Cosine times the original times that as a chain.
No.
Yeah, I think so.
So it's not cosine times. It's cosine of.
Yeah, cosine of.
What is the second term's derivative?
Minus 2 times cosine of the original function.
I leave it as an exercise for you to use product rule to take that derivative and show that you get the same thing. So now that you're shaking your head, I'm going to make it an actual graded assignment.
She's a head.
You shake our heads, yes, then you won't do that.
And speaking of, I think I left off with a function, didn't I? Did I not actually take that derivative?
Oh, yeah.
The nested square root?
Yeah, that one. No.
That's a shame. Good test question. Right, so this is kind of the same idea. You can use either product rule or doing sum to product, or product to sum. So, I'm gonna skip that one because it's boring. We've done something like it already. What kind of function are we dealing with?
Potion.
And what did the quotient rule say?
You want me to read the formula or?
Just tell me what it is.
The bottom function times the derivative of the top function minus the top function times the derivative of the bottom over the bottom square.
Derivative of the top.
Cos times cos, and then the original function minus x times 4 is 1. So this is 4 cos parentheses 4x plus 1.
Derivative of the bottom.
3 times 5x minus 9 squared times 5.
And then square root of e to the 6th power.
Can you clarify on that 15 there?
So did you hear what he said the derivative was? 3 times 5x minus 9 squared, and then times 5. Alright, so power, bring down the power, subtract 1. That's where the 3 times the function squared comes from. Now what's the derivative of the function? What's the derivative of 5x minus 9?
Oh, yeah,
That's where the times 5 comes from.
got it.
Simplify. Factor out 5x minus 9 squared. And sadly, there's nothing else that can be factored out.
So I'm going to use these trig ones. So I'm doing.
Can you reduce the 5x minus 9 to the square with the bottom?
Yeah, I'm not done simplifying. I'm just saying there's nothing else we can factor.
Oh, okay.
And then, yes, that will simplify further, right? Shouldn't have to say this. Trigger functions. Those two are clearly not equal. Yet I inevitably have students say it is. Just like Sine of x over sine of y is not x over y.
Would that be sine of x over y? Or just no?
No, there's no simplification. As I said, I shouldn't have to say it, but I do. Don't be one of them. You'll make me very sad. Derivative of the top.
Eight times 4x plus 1.
Derivative of the bottom.
Secant squared of 5x times 5, or 5 secant squared 5x.
Let's see, factor out 4x plus 1. It's 4x plus 1. That probably wasn't necessary there, was it? Now that I looked at factoring out that 4x plus 1 probably wasn't necessary. But I can still rewrite it. I can rewrite this as a non-quotient. Divide each term of the numerator by tangent squared. Tangent over tangent squared, 1 over tangent. And isn't 1 over tangent cotangent? Secant squared over tangent squared. One over sine squared. Which is just cosecant squared. See, to me, that is a lot simpler than the original. Find the 100th derivative of cosine.
After a while, we would just be getting 0 because we're finding derivative of x over so. Alright,
You'll never get x out of this derivative because it's a trig function. It's just cosine. Why?
Because it goes just in this loop of cosine, negative sine, sine. So, and 4 goes into 125 times. So it just ends up being cosine.
Every fourth derivative repeats. Resets the cycle. So the 100th derivative is just cosine itself. Assume m and b are real numbers.
Would just be x times cosine of x plus b.
Not x. Not just m.
m plus b times the cosine of mx plus b.
I do agree there's a cosine of mx plus b. What's the coefficient?
Get that calculator here.
M to the 21st. Each time you take the derivative, you're multiplying by m. So you're doing it 21 times, so you're multiplying m 21 times. So you were close, except you were adding m. You were adding m 200 times. That's why sine and cosine are awesome. There's one function that's better. We'll be studying that very soon.
One trig function or a function in general?
No, function in general. The derivative of it is just so difficult.
Is that what makes it fun?
Yep.
Okay.
Good on the trig functions? Excellent. Moving on. Exponential and logarithmic functions. And then after that, we just have 6 more functions to study. The inverse trig. Yes, we will be studying those. For some reason, they love to leave it till Calc 2, which makes no sense. It's much better to study in Calc 1. What is the exponential function?
Any number to the power of x.
Any number?
There's a specific number.
Constant to the power of x.
Any constant?
One. It's e.
There are two restrictions on B.
And it not equal to 0.
I agree. But there's more to the restriction than that.
It also has to be non-negative.
So B has to be positive. And not equal to 1. B is your base. The derivative of the exponential function is b to the x times log of b. So there are two bases in general that are used more than any other base. What's one of them?
Okay.
It's called your common base. What's the other one? That's called your natural base. Another base that's common, especially if you're into programming and computer science, is base 2. In fact, any power of 2, base. Right, so I know they have 64-bit operating system. I don't know if that's 128-bit yet. I'm not sure if that's 128. But that would be the next one.
Oh no, it hasn't.
So this is the really hard derivative. Hope you're prepared. Derivative of e to the x is e to the x.
Did you show us that earlier in the semester?
E to the x is the only function that I'm aware of that doesn't change. Its rate of change is itself. So now for the log functions. Which is the inverse of the exponential. Derivative of log base b of x. 1 over x log of b. Derivative of log of x is just 1 over x.
You said this is Calc 2 content?
No, the inverse trig is usually they want it in Calc 2, even though it's in the Calc 1 chapters. So, what's the derivative?
E to the power of 3t to the second plus t minus 1.
What are you missing? Chain rule. So you have to take the derivative of the exponent. So what is the derivative of the exponent?
6t plus 1.
This leads to the general rule. Derivative with respect to x of e to the u prime e to the u. Just go ahead and write it here. Right, general rule for log. Derivative log u prime over u. Fine.
Function the second power. Times 1 over x plus 2x.
just write it under one or over one denominator. What kind of function are we dealing with?
Exponential.
What's the base?
2.
What is the derivative of a base 2 exponential?
You said earlier that's a power of 2, right?
Not power of 2. Base 2.
It's the function times the natural log of 2.
Now chain rule. What has to be multiplied? What was it? For some reason I wrote x squared instead of x cubed. And generally speaking, we write log of 2 at the very end. But you don't have to. And if you wanted to keep the constants up front, then you could write log of 2 out in front. So how do you do this one? So we have a log function, right? What is the derivative of it? What's the derivative of a log?
1 over x. Times 2x.
That's only one way. In this case, it doesn't really matter, but for some more complicated logs, it might. So you should remember from pre-cal, doing problems that required you to expand a logarithm. Write a log as a linear combination, then your pre-cal teacher failed you. And this is done using the laws of logs.
Can I take a crack at it? Alright guys, natural log of x
So if you don't remember your laws of logs, look them up. Because at the end of derivatives, there is a method that's going to require their use. Log of x squared is the same as 2 log of x. Oh. But now that's just a constant multiple. So it's 2 times the derivative of log, which is 2 over x. Bear in mind, they are not the same.
Would it be different if the square was directly attached to the?
No. Those two on the right are the same.
Well, for sine and cosine, it's not like
Same thing.
the same thing.
Sine squared is the same as sine of x all squared. It's just a matter of where to rewrite it. Right, so again, general notation. If you take a function, you can write it that way. With one exception.
All negatives or just negative?
Just negative 1. That 1 on the right means the inverse of f, not the reciprocal of f. Whereas the one on the left would be the reciprocal of f. What is G prime?
Just 4?
What is it?
Is it just 4? Or is it R prime?
4R times ln of 4.
4r.
4 to the power of r times ln.
Again, I've seen this. Four to the r is not a power function, it is an exponential function. So you don't use power rule, you use exponential rule. I'll draw a sad face there to say that is not right. That just makes me sad. If you do that on a test, you might find some adult beverage stains. It's going to cause me to drink. I have to call them adult sodas. And my kids know that they can't have it. How do you want to tackle this?
Start out most
You want to use quotient rule?
Yes.
Go ahead, be my guest.
All right.
Let me know when you're done. Obviously, that's not the route I'm going to take. Don't you also have laws of exponents? Isn't that just 3 halves raised to the W? What kind of function is that now? That's not a power, that's an exponential. Now I need to have 1 adult beverage when I get home. Keep going, I have the whole weekend off, so. So what's that derivative, given that's exponential?
3/2 W ln.
Which is precisely what you're getting when you do quotient rule, with a lot more algebra. I know because I have verified it. Did you finish quotient, by the way?
I went to look up the power rules, and I found all those. Oh, wait.
How do we have to do this one?
And that one for sure has to be the quotient rule.
This, you don't have a choice. This is quotient. Well, technically, you don't have to use quotient. You could bring it up as a negative exponent and then use power, or not power, sorry, product. Yeah. Quotient rules, now that we know chain rule, quotient rule is technically not needed. This is how I used to do quotient rule, because I never remembered it. So I'd always just write as a product and use product rule and simplify it at the end. But you can only do that once you know chain rule. But we are going to use quotient rule. Three to the t plus 2 times what?
Times 2t times the natural logs of 2.
2t.
2 to the power t, sorry.
Then it'll be 2 to the t plus 3 times what?
Three to the t ln 3.
Simplify that. Two to the t times 3 to the t is what?
I want to say 6 to T, but I don't know.
What's 6 to the t? Two times 2 to the t.
That can be simplified. See, calculus is easy. Algebra is hard. You don't remember your laws of exponents. 2 and 2 to the t, don't they have the same base? T times 1. That is one way you could write it. That's how I'm going to keep it. You could also write it as 2 to the t times log of 4. Right? 2 log 2 is log of 2 squared. Two to the t times 3 to the t we already know. 3 to the t times 3. Or you could also write it as 3 to the t times log 27. 3 cubed is 27. That can still be simplified. It's just a matter of, does it look better? And I'll let you decide that. Factor 6 to the t out, you're left with log 2 minus log 3. Law of log says that is log of 2/3. So again, that's now a matter of preference. I personally don't like that form. Simply because it makes it look like it's a complex fraction. So I'd stick with that. Anyone want to do that one? How'd everyone do that one?
Could we do the product was like you said to make the denominator to the -1?
Could do that. There's an easier way. How many terms are in the denominator? So why not just split it into 2 different fractions? So you have that. But I can rewrite 1 over 2 to the W. There's 1/2 raised to the W.
That work if the numerator wasn't 1?
No. No, that wouldn't. 1 is the only number that when you raise it any power stays the same. Oh, look how easy that is now. But what I could do is, let's say that was a 3 plus 3. I could then just write that as 3 times 1/2 to the W. So you'd essentially just go down to the same thing at that point. What's that derivative then?
To the W times the natural log of 3 over 2 plus 1/2 to the W times the natural log of 1/2.
Which can now be simplified. Just to make it look nicer. Or, if you prefer to keep it as 1 over 2 to the W, that's fine. But log of 1/2 is the same as negative log 2. We'll continue that on Monday. I only have a few times left, so we might get done early, which means if I do, I'll be able to work on the project as well on Monday. Have a good weekend.